This question asks us about a practical musical exam, and there are two ways to pass it. First way is to pass it on your first attempt, and the second way is to pass it on your second attempt. As with music exams, you can pass with distinction, you can get an ordinary pass, or you can fail it. And then if you fail it, then you get an opportunity to take the test again. So first thing we'll do is we'll fill in the probability trees. So we're told that 25% pass with distinction. So then this is in their first attempt. So 0.25 here. We're told 0.45 then gain an ordinary pass, which means the rest fail. So we can say that 0.3 is the probability that they fail. We're then told for those taking the examination the second time, they pass with distinction is 0.05. As you can imagine, that's quite likely. If they fail, chances are pretty slim that they'll pass with distinction the next time. We're told 70% for ordinary pass, which then leaves 0.25 for them to fail for the second time. So if we start working our way through these, so if we go over to the right hand side here, part 1, A talks about the probability they fail the exam. So as you can see from the probability tree diagram, the probability that they fail and then they fail again is simply just 0.3 multiplied by 0.25. So remember, we multiply along the branches, so then that's 0.075. So as you can see, it is quite unlikely that they will actually fail twice. Second part of this then, it says what is the probability they will pass the exam with or without distinction. So if you think about this, the probability they pass is 1 minus the probability they fail. So if the probability they fail after one attempt or two attempts is 0.075, then the probability that they pass, whether that's an ordinary pass or with distinction, is just 1 minus the probability that they fail, which will give you 0.925. Okay, part 2 then asks us to find the probability that this randomly chosen candidate passes with distinction. So the first thing really I think we have to do is we have to think about what these events are. So if we say that the event A is the candidate passes, and then B is the candidate passes with distinction. What we're actually looking for is we're looking for the probability they pass with distinction given the fact that they passed. So what we're really looking for here is the probability of B given A, which we know using Bayes' theorem is the probability of A and B divided by the probability of B. Now we already have the probability of A, that's from part 1, the probability they pass, which is 0.925. What we now need is the probability that they pass and they pass with distinction. So let's think about the two options that could be. So the probability that they pass and they pass with distinction could be here, okay, where you've got 0.25, or it could be that they fail and then pass with distinction, which will be 0.3 times 0.05. So let's write these wee bits down. So we've got this. So this will be equal to 0.25 plus 0.3 times 0.05, and that is all divided by 0.925. So quite simply, you put that into your calculator and you should come out with 0.286, and that's rounded to 3 significant figures. Part 3 tells us about Jill and Joe, who are two randomly chosen students, and we want to find the probabilities that they both pass, but just one of them needs a second attempt, and for part B, that Jill gets a better result than Joe. So let's look at part 3, and we'll deal with section A first. So first thing we'll do is we'll write down kind of a couple of things that we know, and a couple of things that we can work out. So first, the probability that they pass first time, okay, is going to be 0.25 plus 0.45, so that's 0.7. The probability that they pass second time, so this is just the probability that one person passes first time and one person passes second time, is going to be 0.3 multiplied by 0.75, so that's whether they pass with distinction or they pass with an ordinary pass, and that will give you 0.225. So far we know the probability that they pass the first time is 0.7, the probability that they pass the second time is 0.225. Now, let's think about the probability that Jill passes first and Joe passes second. Okay, so that is going to be equal to 0.7 multiplied by 0.225. Okay, which is quite simply, when you put that in your calculator, it gives you 0.1575. How about then the probability that Joe passes first and Jill passes second? You can see that's going to be the exact same thing. Okay, it's going to be 0.7 times 0.225, which again gives you 0.1575. We're then asked, what is the probability that both pass, but just one needs a second attempt? Okay, well, if we look at these two options we've got here, these deal with them both passing. Okay, so this one they both pass, Jill's first, Joe's second. This one, they both pass, Joe's first, Jill's on second. So to find the probability that both of them pass and only one of them needs a second attempt, then we're quite simply just going to add those two together. So 0.1575 plus 0.1575 will give us 0.315. Now let's think about part B. So we want to know the probability that Jill gets a better result than Joe. Right, again, let's have a think about some of the things that we know. So the probability of distinction, we know from part 2 is just 0.265. Therefore, the probability of an ordinary pass is 0.925 minus 0.265, which leaves us with 0.66. And the probability then that they fail, we also know that, okay, from earlier on from part 1, and that is 0.075. Right, let's think about the probability then that Joe fails and Jill passes. So the probability that Joe fails and Jill passes, okay, is going to be equal to 0.075 multiplied by 0.925, which gives you 0.069375. Okay, then so we've got the probability that Joe fails and Jill passes is 0.69375. We'll do that on our calculator. Now if you think about the probability that Joe gets an ordinary pass and Jill gets a distinction pass, okay, using the numbers that we have up there, we're going to do 0.66 for an ordinary pass times 0.265 for a distinction pass, and that will give you 0.1749. As you can see, those are the two options for Jill to get a better result than Joe. So quite simply, if either of those happen, Jill will get a better result. So to find the probability that Jill gets a better result, we are going to add those two together. Okay, so if we add those two together, that will lead you to 0.244, and that's rounded to 3 significant figures. Just to summarise some of the key things then that we discussed here. First thing is to make sure we label our probability tree correctly. You need to remember that in order to find the probability that two events happen, you multiply the probabilities, and then if there's any other different options, then you're going to add them. So that's just the add, and you multiply, or you add. We then worked through, we found the probability that they fail. The probability they pass is 1 minus that, so that was part 1. Part 2, we had a wee bit of conditional probability, and then part 3, we started to work with Jill and Joe and kind of comparing their progress and working through the different probabilities. Do take another look at that, maybe even watch that again after you've read the question, and make sure all that makes complete sense. It's nothing more complicated than just using the basic laws of probability and what we already know about setting up particular events.